station, this is Houston. Are you ready for the event?
Why, yes, we are.
Weather Channel, this is Mission Control Houston. Please call station for a voice check.
Station, this is Jen Carfagno. How do you hear me?
Jen, we have you loud and clear. How us?
Excellent. Excellent. I can hear you loud and clear. Very exciting. So we're ready to jump right in?
We're ready.
Excellent. Well, Tracy, I'll start with you. Oh, I can see you guys now. This is very exciting. Tracy, you just arrived at the ISS in March. So how was your travel getting there? And what were your feelings when you moved back in, because this wasn't your first time there?
Well, it's funny you should ask, because we actually, my crew and I on the Soyuz had 2 trips to the launch pad, so getting here was a little later than we expected for the launch scrub that we had, and then we turned back around, did it again. But instead of taking 2 orbits to get here, we took 2.5 days. And so getting to the space station came with lots of anticipation. But it was great to come through the hatch and to see all of my crewmates and good friends, and to see this wonderful place that in a lot of ways hasn't changed. And so it's been a really good time getting to know the space station again from the inside, and soon we hope on the outside, and to spend time with these guys.
Excellent, excellent. Matt, we've had a lot of reasons to look up on Earth lately. We had the total solar eclipse in April, the May G5 geomagnetic storm that allowed millions to see the aurora all over the globe. But Matt, what was the eclipse experience like for you? Did it affect any of your solar-powered equipment there on the ISS?
Oh, so for the aurora and eclipse, as soon as you said aurora and eclipse, I got super excited over here. I was so fixated on aurora the past couple days. It's been so exciting, but the eclipse was, of course, incredible. We're moving so fast that we just ripped right through the shadow so quick, but we got to see it as a crew. We got to see it out the cupola. We got to set up amazing time lapses to capture it. But we actually made a couple passes around the Earth over the shadow in better and better positions. But at 17,500 miles an hour, you just rip right through the shadow, so no real appreciable effect on the station solar. Although, to be honest, I am a nerd, and I have lots of data I track, and one of which is my home solar, and so I could actually see the notch in my home solar as the shadow went by.
That's really cool. That's fascinating. Tracy, could you all see the aurora on the ISS? You know, when we are on Earth, we know it can cause some technical issues, maybe for planes, for GPS. And does it cause any technical issues for you there on the ISS?
No technical issues. The only issue that we have is getting to the window fast enough, because we're working through every orbit pass except when we're sleeping, and so the timing of getting to it. But I'll let these guys describe to you the disappointment we had during the height of the aurora season for us up here. Go ahead.
Well. So in a fit of incredible irony, while the Earth was enjoying this great big geomagnetic event, which really lights up the aurora, like sort of pouring gasoline onto the fire, we were in a position with our orbit where we really couldn't see much. You know, we have kind of an equivalent of seasons, because our orbital plane kind of goes around with the Earth, and as the Earth goes around the sun, that changes our orbit's orientation to the sun. And we were at a time when we were mostly in daylight. So it's like being in the high Arctic during the summer. It's mostly daylight. So we were getting all these amazing photographs from the ground of people in California and Italy seeing the aurora, wondering how amazing it was on station. And we were just wallowing in our self-pity up here because we couldn't see it.
Oh, my goodness. Isn't that timing? But I'm sure you get to see it many other times, right, Mike?
I was just saying, Jen, I hope one of us gets to describe what an aurora looks like from the space station, because it is nothing short of amazing. When you look at it from Earth, you see it in 2 dimensions. And when you see it from space, above the atmosphere, we see it in 3 dimensions. It actually looks like it's dancing. As much as it changes from your view on the ground, it changes up here, but in height as well as in width and spans. And so it's amazing the anticipation that we have. Of course, when you're in the northern latitudes, you look up in the sky and there it is. But for us, we actually approach the aurora and then we leave the aurora, and the anticipation and the angst that we feel as it passes us by and we know we have to wait a while to see it again. All of those emotions, it's just like a cacophony of lights and just really exciting sensations as we watch chemistry and photochemistry happen right before our eyes, which to some of us is very near and dear.
Tracy's brought all
yours
these
especially.
emotions in there with that, but it's important to keep in mind that when we are looking out and seeing the aurora, we're also seeing the curvature of the Earth. We're seeing the aurora glued to that curvature. We're seeing city lights, and sometimes you see lightning storms and stars and satellites, and you're taking all that in when you're seeing aurora. That's part of what makes it just unbelievably breathtaking.
And so special. And I mean, what a description here, and kind of unexpected too. I really appreciate that. I didn't know how it would appear to you in space. I want to switch gears for a moment. And Mike wanted to talk about sleeping in space, because there's so much talk these days about the importance of getting a good night's sleep. Do you actually sleep good in space, and do you sleep better in space or on Earth?
Just like on the ground, that can be very individualistic. Everybody has a certain relationship with sleep and their life cadence. And the same is true up here. I would say my personal experience is I just love kind of floating inside my sleeping bag. It's my 3rd favorite place on the space station after the windows and the galley table. And it's just really nice to get our rack time up here. But my experience, and I know the same is true with others, is that you can have the same level of alertness for a little bit less sleep up here. But there's all sorts of things that perturb it. You don't have a one definitive sunrise or sunset. You get 16 of those a day. There's no rooster crowing. You declare it morning when you turn on the lights and the alarm goes off, and it's very artificially regulated like would be on a submarine. So everybody's a little bit different, but I think sleep is adequate. But it is also something we don't understand completely, and it's the focus of a goodly bit of our research up here.
Right. I'm thinking about people with shift work too. They kind of mimic some of what you do with, you don't wake up with the rooster or with the sunlight. You wake up with the alarm. I understand that space physics and life support work are on the to-do list for Expedition 71. So Matt, I'm going to throw the physics question to you. What kind of discoveries are you making?
We got lots of scientists that said lots of good science up here, and they're doing most of the discoveries. We're their eyes and ears to set it up and tear it down. But really, what we're building is just a foundation of decades of experience of operating hardware in space for life support. We're in the upper 90% for our water reclamation and recycling, so that we don't have to ship heavy water up here. Today's coffee is tomorrow's coffee is the classic phrase. But yesterday I changed out a brine processor, which just allows us to eke out a couple more percentage points in terms of water reclamation. So in terms of discoveries, it's as much as about the new discoveries as it just figuring out how to make things last for such a long time in space. If you think about the Apollo program was about touching the moon, getting there, and coming back, and you only had to make hardware that lasted just that short mission. In fact, like less than 10 days. As we go forward with the Artemis program, it's about making hardware that lasts years and years and years of time in hostile environments. So that's really what we're doing, is we're putting time and humans for long periods of time on hardware to figure it out.
Yeah, excellent. The ultimate kind of reduce, reuse, recycle situation up there. Tracy, I've got chemistry questions for you. I saw an ISS post about electron precipitation, and it got me thinking, do we need to be worried about that kind of precipitation here on the Weather Channel?
Anytime we talk about electrons, I get kind of excited. But precipitation, I've never put those two words together. Electron precipitation. I don't think we need to be worried at all. we need to be worried if electrons stop spinning, because think about that. That's going to be a problem. But no, electrons are good. We need them up here to produce light. We need them up here to power our equipment and our scientific experiments. And the only precipitation I guess we got to worry about is what comes from the sun blasting our way. But we've got a whole team of super duper smart people that are tracking that stuff to give us fair warning. I don't know. We could just keep talking about electrons.
Yeah. Well, you know, actually, speaking of. Do you have anything else to say about electrons? Happy to hear it, actually.
They're scared.
But speaking of, you mentioned, I'll put precipitation in quotes, coming from the sun, but the energy that we get from the sun, and I've been paying a lot of attention to that since we were talking about the aurora and the G5 geomagnetic storm. What do you do when there's a lot of energy directed at the ISS here? Is it just everyone inside? What is the protocol?
We have lots of policies and procedures. We work for the government, but it is well managed. You know, we had these massive storms that were going on, but you know, our first layer of protection is actually pretty much organic. We have the Van Allen belt, which takes a lot of that and directs it away from where we're at and protects us. It's one of the reasons we put the space station where we put it, is to be inside the Van Allen belt. Again, another concern as we go forward with Artemis is how we venture outside the Van Allen belt. Inside of that, you know, we have something that we experience on a regular basis, which is the South Atlantic anomaly, and you know, some of the radiation we experienced going through that was bigger than we would experience during the magnetic storms as we passed near the poles on the north and south side. Additionally, our orbit is limited to something a little bit less than 52 degrees inclination, so we were pretty well protected in this last storm. We had mitigations. Our teams know exactly where on space station are more protected or more insulated from radiation that we can go. And if we really have to, we have procedures to bunker down and surround ourselves with radiation blocking material.
Okay, interesting. Thank you.
One little add
Mike.
to that.
Yeah.
You know, we're all kind of considered radiation workers. We're all kind of considered radiation workers. And I was fishing out my radiation dosimeter, which each of us have. And they give us some real-time readings. And aside from those particles that we get from Mr. Sun, we're always bathed in galactic cosmic rays, and that's actually where we get some of our higher equivalent doses, because those are coming in fast, they're high mass, and they pack a lot of energy. And as much as anything, that's what kind of limits our stay in space. So it's something we think about from a human standpoint, a medical endurance standpoint, quite a lot.
Are any of those, though, positive or beneficial? I'm thinking of the red light and blue light masks. You might have seen them on social media that are all the rage right now. And, you know, certainly just the vitamin D we get out of sunlight here. Is there a benefit to some of these?
Well, I have told my children that the space radiation I get up here gives me superpowers. They don't buy that. But in general, that's what we're talking about is really ionizing radiation, very different from the color spectrum that might be all the rage down there. And we don't think there's really anything beneficial, but there is a line of research that looks at low doses, continual low doses of radiation exposure, which does have some interesting biological effects that may not all be bad. Right now, we treat it as something that's something fairly bad and something to be very, very careful of as we accumulate the absorbed radiation doses. So that's kind of where our headspace is.
Yeah, it makes sense. I'm gonna stay on this line of questioning, Mike, with you, because I know it's probably safe to say when someone asks, "Is there a doctor on board?" you probably raise your hand. But I wanted to ask, what kind of medical discoveries is the team working on specifically?
Well, you know, in my mind, the biggest experience and knowledge base we get out of here is having people up here for long periods of time and studying every system, because we know every system changes in zero gravity. And it shows us a couple of things. It shows us what the space-unique environment does to us, and that is changes to our bones and our muscles, our immune system, our cardiovascular system, how we're regulated, our brain shifts, immune system, everything changes. But it also shows how adaptable the human organism is in a way that we never really could have imagined. You know, when you take away the dominant force of gravity, you find things that you wouldn't have found on the ground, and you think a couple of things that, number one, this seems to adapt us for zero gravity. Why that happens, not really sure. But number two, you find things that you didn't know the body was capable of doing, and that includes some of the ways that our blood system is regulated, some of the ways our brain changes up here, and everything from sodium storage in pools that we didn't even know existed in the human to counterintuitive changes in blood flow. We do get some vision changes. Whether those are a good thing or a bad thing is still up for grabs, but there's such global changes going on that it warrants a lot of study, and it informs us of the basic knowledge base of human physiology.
The body is so fascinating. It really is. Tracy, I wanted to switch gears again. I saw a really neat story about AstroBee Zero Robotics, which allowed students to write software to control a free-flying robot on the ISS. I thought, how cool was that? So how did that go, and how did it go working with the students?
Well, it's a lot of fun in a nutshell. But we have yet to start working directly with the students because it's a competition. The Zero G part of it's a competition. Right now, what we've been involved with is getting the robots ready and kind of setting a baseline for how they will respond once they get this software that the students have written. And so we've got 3 AstroBees, the free-flying robots. I think their names are Bumble, Queen, and Honey. And so, everybody's got to have a name up here, and they each have different personalities, and we've been working to help the ground team set them up, get them in position so that they can receive commands, and then I've also got to do some fun sign language, basically, with the AstroBees in their gesture recognition software. And so I'm not sure exactly where all we're going to go with that, but I'm super pumped to be a part of it.
Yeah, that's really neat. Matt, as you know, and from Colorado, of course, you know firsthand how hard we are caring about our environment, how hard we're working to clean up our planet Earth. But I wanted to ask you about space junk. How often is space junk a threat to your work up there? And do you see it flying by?
Do we see other stuff in space? Funny you asked. Just the other night, I was in the cupola after work, and I was playing around with some cameras, and it was incredible to see other satellites out there. Over the past couple of years, we've seen this, probably exponential growth in number of satellites being launched into space, and it's really cool if this is the Earth in front of us, and we're here, and we're in the dark. The sun is on the other side of the Earth. And you can see the satellites that are up here, kind of like our organic satellite, the moon, reflecting light from the sun off the satellite into our eyes and into the cameras. And the other night, probably on a single, just maybe 5 to 10 minutes before sunrise, there's beautiful orange and green glow, and you could see the light reflecting from the sun off the satellites into our eyeballs, and it looked like they were swirling around. At least 100 satellites you could see with the naked eye. It was incredible. Was able to make a couple time lapse of the event. With regards to space debris and a threat, we have lots of people, international effort tracking space debris, and occasionally we'll get warnings about it might be an issue, and we have, of course, procedures to handle it. We can maneuver the space station as required with hours and hours of notice. We're able to do it. So lots of good efforts to protect us, and lots of cool stuff in low Earth orbit right now.
Very interesting. I really appreciate this time with y'all. This is really exciting. Matt Dominick and Mike Baird and Tracy Dyson, thank you so much for joining me from the ISS. This is literally an out-of-this-world conversation, and I can't wait to share it with everyone on the Weather Channel.
Awesome.
Really a pleasure to talk to you, Jen.
Yeah, thanks a lot, Jen. This has been a lot of fun for us, too. Yeah, thanks a lot.
Station is Houston ACR. That concludes the event.
Thank you to all the participants. Station, we are now resuming operational audio communications.